Let's learn how to factor binomial expressions using the difference of squares formula. Remember to download the corresponding PDF using the link in the description so that you can follow along as I work through these examples. Now, the difference of squares formula is very simple. A squared minus b squared can always be written as a minus b times a plus b. And it's just a matter of figuring out what the a and the b are for your specific problem. The trick is to take your binomial and write it as something squared minus something else squared. Let's try that with this first example. Something squared minus something else squared. Now for this first set of parentheses, x squared can just be written as x squared. 9 can be written as 3 squared. Something squared minus something else squared. And then we can apply the formula directly. This is now x minus 3 times x plus 3. Next example. There's a different variable, it doesn't change anything. Formula will still work the same way. Something squared, so theta squared, minus, and 81 can be written as 9 squared. So now we'll apply the formula. Theta minus 9 times theta plus 9. Now the next example has a plus in the middle of the two terms. This is the difference of squares. So we cannot apply the formula directly to this problem. For now, we're going to call this prime. And that just means it doesn't factor any further using real numbers. We'll go over in another video how we can factor this using imaginary or complex numbers. But for now, we're just going to call it prime. 64 minus y squared. This is one of the most common mistakes I see in my classes. When the variable comes after the number, the formula still works the same way. And if you need to keep writing it as we've been doing something squared minus something else squared, you can. In this case, we'll write it as 8 squared minus y squared. And then apply the formula. But remember, 8 is your A and y is your B. So make sure you get the order right. This is 8 minus y times 8 plus y. And this is not the same thing as y minus 8, y plus 8. This matches with this, that's true, but y minus 8 is different than 8 minus y. So let's not make this mistake. So what's different in this next example now that we have coefficients? Actually, not a whole lot. We can keep doing our trick, something squared minus something else squared. But what do we put inside these parentheses? The expression that's going inside each parentheses is actually the square root of each of these terms. The square root of 4x squared, or the number that gives you 4x squared when you square it, is 2x. And the square root of 9z squared is 3z. And then I apply the formula. 2x minus 3z times 2x plus 3z. Now let's make things a little more difficult. 5x squared minus 8. We'll write this as something squared minus something else squared. For the 5x squared, it's very easy to get x squared by just squaring x. But what number squared gives you 5? Not a nice number, but we can just write that as the square root of 5. Notice I'm very careful to keep the x from being underneath the radical. Radical only belongs to the 5. Same thing with the 8. What number squared gives you 8? Well, it's not a nice number, so we'll just write it as the square root of 8. Then we can apply the formula. Square root of 5x minus square root of 8 times the square root of 5x plus square root of 8. So let's bring everything together here on our last example. Well, this one's a little more complicated, but that's okay. This doesn't look like a difference of squares initially. We have two variables raised to the fourth power, but we'll try and apply what we learned and write this as something squared minus something squared. Just like before, 20 doesn't have a nice square root, so we will write this as the square root of 20 x squared squared. Now, why does that work? X squared squared is equal to x to the fourth. Properties of exponents. When a number is raised to a power, and that's raised to another power, those exponents will multiply. We'll do the same thing with our second term, minus 4y squared squared. Let's apply the formula. Square root of 20 x squared minus 4y squared times square root of 20 x squared plus 4y squared. Note this second factor. This is a sum of squares, so this will not factor further. Our first factor, however, is another difference of squares. We have a little bit more factoring to do here. As always, something squared minus something else squared, and then we'll bring this factor down. The x part is easy, we'll just have an x. But what squared gives us the square root of 20? In other words, we need to take the square root of the square root of 20. Let's do that off to the side. Square root of the square root of 20. This looks a little messy, so let's write this with exponents. This is 20, the 1/2 power, and then that is being raised to the 1/2 as well. That's the two square roots. Same property as before. When we take a power to a power, the exponents will multiply. So we will have 20 to the 1/4 power, or the fourth root of 20. This will be the fourth root of 20 times x, all squared. The second term is not too bad. This is just 2y squared. Now let's apply the formula one last time. Fourth root of 20 x minus 2y times the fourth root of 20 x plus 2y. That factorization represents this factor. And then we'll carry this factor down. And that's as far as we can factor that expression using real numbers. So if you found this video helpful, make sure to like and subscribe for more math tutorials. And if you have any questions, drop them in the comments or join us on Discord. Links are in the description. See you next time. God bless.